In last class, we discussed about pointers. If just like 20 people that is in the class, and we also have the video in our course web page. And if you guys, if you don't know like where it is, just I'm showing you. So these links mean like C stands for code. The code what we wrote in the last class is here, and this stands for the V11. This stands for the video of the 11th lecture, and the videos are loaded here. Please go and watch this. What to say about the raw, and we discussed about both raw pointers and smart pointers. But just to make sure that you understand everything that we're discussing today, I'm just giving a quick review about raw pointers today. Okay, right now. So it's a very quick review. So if you want to like dynamically allocate memory, there are two types of memory in your RAM. You can think that this is your RAM, okay? And when your program is using your random access memory or the main memory, there are two parts in it. One part is called a stack, and the other part is called a heap. Okay, there are two parts in it. And whenever you write some code like, let's say, int star b, okay, this code in C++ just means that p on the right hand side. Okay, we'll go one by one. First, just this side on the right hand side, we say this is very similar. This syntax is very similar to Java. We say new int of 10. Okay, which just means allocate memory for storing 10 integers. And this first thing will happen on the heap, and you can think of it like it's just like an array in memory that will be like from 0 to 9. There will be 10 elements allocated, and each element can store one integer. Okay, and the second step here is creating a variable called p. This happens on the stack, and this syntax here, the star before that, just means that p is a pointer. P, you should just read it as p is a pointer to an integer. This star just means pointer. This syntax just means p is a pointer to an integer. And what happens on the stack, because this is like there is a variable called p that is created, and this can store the address of an integer variable. Okay, and since this array of integers, 10 integers, each and every element in this array will have an address. Let's say if this starts at 0x1000, 0x just means it's hexadecimal number. The next element will be at 0x104 because each integer will occupy 4 bytes. And each address is just an address of a single byte, and it goes on like this. And so now this p will just contain the address of the first integer. So this just means this contains address of the first integer of this array, and so now we say that p is a pointer to this dynamically allocated or dynamically created array on the stack. Why we call this as dynamically allocated or dynamically created is like when your program is executing, you can decide how many integers you want to store. So this particular line of code allocates 10 times 4 because each integer needs 4 bytes of storage in the memory. So it allocates 40 bytes of memory for you on the heap, and then creates a pointer variable called p on the stack, and then stores the address of the first integer in that array of integers that you got here. And then this just means the equal signs just make sure that this is just a pointer. This has the address of the first element, and because we have this particular thing, after this we can just go and access this particular element saying like p of 0 equals, let's say 7. If you say p of 0 equals 7, then p just points here, then you can access this entire memory as an array. So p of 0 will become 7, then p of 1 equals 3, will just make this, the first element in this array as 3. This is how you use pointers to access like memory. Okay. This was the content of this was the main content of the previous class, and we also saw something about smart pointers, where in modern C++ we will not, if you are writing application level programs, we will not be using, these are called raw pointers. Okay, these are C type raw pointers. We will not be using raw pointers, but instead we have some higher level classes that have been built for us, where we can make sure that those classes are called smart pointers and smart pointers, and the types that we discussed are shared pointers and unique pointers, and you can like go through the video to see how to create that. Yeah.
This new keyword, so we haven't really used that too much thus far.
Because till now we did not even allocate any memory on the heap. Whatever we did till now, that's a very good question. We did not even use new keyword till now in this like 368, right, in this course, right? The main reason is whatever we had, all the memory, be it a vector, whatever it is, we only created it on the stack. But think about it, vector is a dynamically sized array, right? So vector in turn would have used the heap for us to create, like if you had like initially 10 elements and then if you pushed back like 10 more elements, then how does it manage memory? It's like using the heap. So vector, the data structure vector that we are using till now, the container, internally uses the heap for managing the elements that we are storing. But the v variable, if you say like vector v, that v variable is on the stack. Okay. So here in dynamically allocated memory, the main thing is whenever you want to like delete stuff, since this is an array of integers, at the end if you want, you as a programmer should make sure once that memory is used, you should actually explicitly delete it. So you just say delete. This is a syntax in C++ for deleting an array of like bytes. Okay, delete p. You just say delete p. So what this does is wherever p is pointing to, okay, this whole array, it will just after this delete p is executed, this whole array will be deleted from memory. It will be gone out of scope. Okay. And after that, it is the programmer's responsibility to make sure that they should not use p again, and to ensure that p should not be used again, usually we will just make p as null pointer, ptr. In C++, this is the way that we specify null in null, which means that this pointer now is pointing nowhere. It will just have null pointer. It's pointing nowhere. Try to access that, there will be a segmentation fault. The operating system will immediately crash your program.
So you don't just say no, there's a keyword null.
Yeah, there's a keyword null pointer, and in C it is called null and it's in caps. You can use that also, but in C++ this is the convention that we follow.
And we can't just say asterisk capitalize null? Like we can't put a pointer on null?
No, we can't. Okay.
Why not?
It will be, if you try to dereference null pointer, it will be a segmentation fault. Okay, so with this quick background on pointers, now we are going to see, okay, how does vectors work, because we are going to create our own vector class. So vector internally is just a dynamically sized array, and so what that means is when we say something like in later code like std vector of n, let's say b. Okay. This code, what it does internally is, again, there will be the stack and the heap, and this variable b will be created on the stack, and immediately there will be some memory that is needed to store the elements that we are going to push back, right? And that memory that we need to actually store the elements will actually be created on the heap. And initially there will be some default size. Something like, maybe initially when you just create a vector without any size given to it, by default, this may vary, but this is just an example. It can have like 16 elements created, okay? And all those 16 elements will be initialized to 0. And B is just on the stack, okay? It will be like this. So actually, if you think about it, this is how an actual vector is implemented. And if you go and add 16 elements, these 16 elements will be filled up. And these will be, since you have created a vector of integers, every element will be an integer. And if you add the 17th element to this particular vector, immediately this vector will be resized. By that, what we mean is this vector immediately will be much more memory allocated for this particular vector. Let's say it will be doubled in size, 0 to 31. And all these elements, the first, this is like 0 to, this is 15. The first 15 elements will be just copied as it is to the new dynamic array. and then now we have 16 more elements here, and now this V will stop pointing here, but instead will start pointing to this dynamic array. And this particular memory of 16 integers will immediately be deleted by the vector class. This is what is happening internally whenever we are using a vector. But we till now did not worry about any of these complexities, because this level of understanding is only needed when we go to the detail like this. For example, now we are at a point where we can write our own library class. We can write our own container because we have all the tools with us that C++ provides. For example, for doing anything like this, now we need dynamic memory allocation. Now we know dynamic memory allocation, we know operator overloading, we know how to write templates, templated class. With all these tools that we have, now we can easily write code like this to get vector working. Does it make sense? And this is what we're going to do right now. Just before we proceed, okay. Again, assume we have a vector V. Okay. Vector of V, say V1, and if we have, assume we have pushed back some 3 elements to this vector, okay, V1. 3, 1, and 2. There are 3 elements in this vector. If we do something like vector of in V2 in braces, we do V1. Can someone tell what will happen here? If we do syntax like this, what will happen here? Yeah, V2 now is a copy of V1. Okay, V2 is a copy of V1, but just think about the diagrams again in stack and heap. We have V1 here, which has some elements here. Let's say 3 elements as of now. Had 3, 1, and 2. Now you just created V2 and you just told copy V1. Now, will V2 just point to the same array in heap, or will it point to a new array? New array, very good. So this actually will create a new array on the heap and copy these elements one by one, 3, 1, and 2, so that V2 is actually totally a different vector than V1, but with just the copy of the elements that V1 had. Okay, this is very important. In a similar way, assume we had code like std vector of int v3, okay, we screen v3, and then we say v3 equals v2. Now what will this code, what will this line do? So again, v3 will be created here, okay, v3 will be created. Now will v3 just point to v2, I mean to this particular array, or again will a copy be created?
Point to V2.
You're saying like it will point here? No. So in the vector semantics and thinks that okay, we are trying to copy a new, we are trying to like make a new vector here, okay, and so it actually again the same thing happens. A new memory is created with the values 3, 1, and 2 copied from here, and just now V3 is a totally different vector. Okay, this is what happens internally in vector. So here we just copied vector V1 to V2. When we just created vector V2 itself, we did that. Here we created vector V3, which was initially, you can think of it just V3 was empty like this, okay? And then we said copy the elements from V2 to V3. So this is very similar to saying int n3, n3 is equal to n2. n2 will still be some value. I will copy that value to n3, right? Another integer. The same semantics happens with vector also. Yeah.
So if we did want them to share the same address, we would use alias.
Yeah. If you just did want to use the same thing, the same, what to say, if you wanted to make V3 point to same V2, what you would do? You would use the reference variable. That's why we need references. So at that time, you would just say something like std vector of int V3, okay? This is not just V3, it is just ampersand V3. It will be ampersand V3. So V3 is a reference to another vector, and that vector is V2. Okay, so what this does is, it just actually says V3 is a reference to V2, so it is just another name. You can think of now V3 as another name for the same vector V2. your question.
You answered my question.
And okay. So with this in mind, so now let's go and create our own vector class. Okay. And yeah, this lecture is named as resource management because here in our class, the vector class that we're going to create is actually managing a resource called memory. Okay, we are managing memory by ourselves. And other types of resource that we can manage manually is like a file. You can think about file I/O. You can manage files manually. Okay, and here we're going to manage memory, and so this is called resource management. And let's first, even before we start the vector class, we can think. So the vector that we're going to create, maybe let's just name it with the capital V. Okay, vector of in. Okay, it's going to be a vector of in V1. Okay, this is how we are going to create our vector. Just note the capitalized V because small v is just for the actual vector, but we are going to create a class with the capital V. Okay, so now if you want to create this particular class, create new class. I think we will just create only the header. Can someone say why we need only the header? Yeah, because it's a templated class. Because it's a templated class, you will not split it into .hpp and .cpp, but we'll just have it in the header. And now here what we are going to do, the first thing is just say, so here I'm trying to show you how to just even get started thinking in terms of templates also, okay? So when we start this class itself, we are just starting with the template and the template type name T. So this vector is a templated class hereafter. Vector of T, okay? And is T counted or not? Sure, so let's just get started, okay? So the private variables, now as we just saw, we definitely need some dynamically allocated array, okay? So for that we need a pointer to store the address of the first element of the array. So if you want a pointer, and this type can be any type. So if you think about the code that we just wrote, we wrote like int star p, right? Here we are just going to say t star. So this is a pointer to some type t. And while thinking about this code, just think that always t is integer. That will be very easy for us to develop this code. Just think t is always integer. So t star, we say elements. These are elements of this particular vector. And then there can be std size underscore t. Size t is for unsigned integers, okay? And the capacity of the vector. What is the vector's total capacity, okay? And std size underscore t, the size of the vector. So size and capacity are different in a vector because when we initially create a vector, we may create number of elements equal to the capacity. We may create 16 elements, okay? But size is just the number of elements that the user has pushed inside the vector. So if the user has pushed only 3 elements in a 16 element array, the size of the vector is 3, but the capacity is 16, okay? And when user has pushed 16 elements and is trying to push the 17th element, then we will go and increase the capacity, okay? This is the difference between size and capacity. And also we need a constant here. The constant is the initial number of elements that we need to have in the vector. And to define a constant, usually we say static const size t, and we just say the constant name. Let's name this as initial size. Okay. These are private variables that we need for a vector class, and the public interface. Let's start with simple things like the default constructor. So the default constructor is going to be here. And in very similar how we do in Java, since this is a templated class, you can directly write your code here itself. Okay. If you had seen my matrix implementation that we shared for A5, it will be like the code will actually be here. There will be no separate declarations and then definitions of the class. Because anyways, it's going in the same file. Okay. This is actually more easy. Okay. So you have vector, and when someone just creates a vector without any arguments, then the capacity is going to be the default capacity, and this initial size we should assign a value, let's say 16, okay? So initially when someone creates vector, the capacity is going to be the initial size. The size of the vector is going to be 0 because there's no elements when they just use the default constructor, and the elements, okay, now this is a pointer, right? Elements is a pointer. Now this is going to point to the actual dynamic array or the memory that we're going to create on the heap now. How do you do that? New t, so new int of, right? We say like new int of so many integers we need. Here it is just new t of the capacity. Does this make sense? Only if this constructor makes sense, you'll be able to understand what we're going to discuss here after. So please ask any questions if you have them right now. Here we're just saying this is a pointed elements, and this elements is pointing to some dynamically created array of capacity. Just think about t as integer again. So int of, let's say 16. 16 memory for 16 integers has been created on the heap, and the address of the first integer is now stored in elements, and you can hereafter access this elements as a normal array. Make sense? Okay. Now if we go to our code here, okay, we need to hash include our vector class, the capital V. So now this should compile. Okay, let's see if this compiles. And this is again incremental coding. Before this even compiles, we should not even write any more code. Okay, so just with the default constructor, let's see if this compiles. So there is some error here. Okay, explicit specialization of non-template class vector. So I think this should not be here. I think I added it wrongly. Very sure. Yeah. So process finished with exit code 0, which means normal program termination. And so our vector has been created. The vector with the default constructor has been created. To just make sure that this is actually working, maybe you can just type some things here, like let's say default constructor, okay? Yeah, do you see this? The default constructor is being printed, and so our vector is actually created, okay? But now there is a problem, okay? We told like whenever we dynamically allocate memory by ourselves, we as programmers should make sure that we should explicitly delete the memory or free that memory because it is on the heap, and if we don't do that, it's called a memory leak. And here our class vector that we are writing is actually managing that memory. The user who is using our class, which is our main program, has no idea that some memory has been created on the heap. Till now think of we were the users, we had no idea that the vector was actually using the heap to create all those things, right? So now it is the vector's responsibility, or the person who's writing this vector class, it is his responsibility, his or her responsibility to make sure that this memory is actually deallocated. When this vector is finished, when the user has finished using our vector object, this memory should be explicitly deallocated. And to do that, we have a special member function in C++, and it's called a destructor. It's very similar to a constructor, just with a tilde sign before it, okay? Just says, now this is the destructor for a vector, which means whenever our vector object is going to be destroyed, execute the code that is inside here. So here we will just say delete, okay, delete the elements. Which means like delete all the elements that this thing points to. It will delete the 16 integers that we just created. So this code is here, just to make sure that this also works properly. We can even like maybe just print it, okay? And we can just say this is a destructor. So now when I run the same main we did not make any changes. Now when we run the main, it says default constructor is called here, and the destructor is called here, and so we can be sure that that memory has been deleted. But can someone say how this destructor is called? We are calling the constructor explicitly in this line, right? But how is this destructor called by itself? Or by, yeah?
Is that garbage collection?
The answer was, is it like garbage collection? No. The answer is, if that is the question, no. It's not garbage collection, yeah.
Is it like when the stack room ends?
Very good. So it's actually, V1 is on the stack, okay? v1, this variable vector now is on the stack, and this stack frame of main, okay, this stack frame goes, this variable goes out of scope when we come to line 9, okay, when we come to line 9, that stack frame of this particular function is destroyed. When that stack frame is destroyed, the variable v1 is destroyed, and when the variable v1 is destroyed, immediately the destructor of that particular class will be invoked. Makes sense?
Can you quickly explain how that's different?
But
Can you quickly explain how that's different? It's too complicated. It's like how that differs from how garbage collection works.
so in garbage collection, so the question was like in Java we had like garbage collection, right? In the garbage collection, here it is more like scope-based resource management. By that we mean the scope of this variable v1 ends with this program. So for sure that variable v1 will only be deleted when it reaches this line 9, when it goes out of scope. But in garbage collection, let's assume we had like an array list, okay? Let's say we have an array list, and if like there are like multiple variables that are pointing to the same array list, okay? Then there will be a count internally which makes sure that okay, there are 3 variables pointing to this memory right now, and so this memory should not be deleted. But if one variable goes out of scope, okay, if it's not pointing that anymore, then that count will become 2, then that count will become 1, and when that count becomes 0, okay, there will be a program called garbage collector which will run internally, which will go through your heap completely and check all the orphaned memory by itself. And since it checks the orphaned memory, it finds out that okay, this particular piece of memory has no pointees, no one is pointing to this particular piece of memory, and so now I'm going to delete this particular piece of memory. But here that is not what's happening, because in C++ we don't have garbage collection, because we use C++ to write like, let's say, performance critical code like databases, okay? And when we are doing databases, if this code is running, and if we had garbage collection similar to Java, when a user, like critical query is given, okay, and if you're waiting for a response, suddenly if the garbage collector kicks in, then it will slow down the time that we get the answer, and that is not at all acceptable in C++. And that is the reason we don't want the we don't want the performance to be like at chance, okay? But that is a very good feature with respect to Java, because Java is written for writing higher level applications where we don't worry about like this level of like control over the machine. Here we have total control over the machine. Okay, makes sense? And understanding this difference between a garbage collector and how C++ destructor works is actually very important to understand the difference between the two languages. Okay?
So when you ran this code before without a destructor,
Pardon?
when you ran the code before without the destructor, is that and then terminated the program, is it still floating around in the heap?
Yeah, so just before this, we did not write the destructor, right? When we did not write the destructor, since we explicitly allocated some memory on the heap, this memory was actually wasted. It was just floating around in the heap, in the RAM, okay? But what would happen is, when our program terminates, okay, when our program itself terminates, the operating system immediately comes and recovers that memory. Okay, but the issue here is, if you write the code like this in some program that is going to run like continuously for a long period of time, like let's say like if you're writing support for Twitter or like for Facebook, something like that, if those servers will be running continuously, and if you write some code like this, and if so many people are using your vector class, and whenever their program is ending, some part of memory is wasted on those machines. And when this keeps on happening continuously, and then your complete machine will suddenly crash, your machine will crash, because there will be no more memory on the RAM. And this particular thing is the reason for memory leak. And in our small pieces of code, we will not like actually leak memory, because operating system immediately reclaims it because our program ends, but those programs will actually not end. Will keep on running. Does it make sense? Okay, with this, then we also have the destructor now, which deletes these elements, okay? And then, now, think about like what are the next thing, how can we proceed creating this vector? We should have like a pushback function, right? Pushback will help us to do some, like add some elements to the vector. So let's write a method called pushback, and I'm just going to make all these things as caps, just to make sure that this is our thing, okay? Pushback, and it does not return anything, and it takes in a element of type T, okay? It takes an element of type T. In our case, we can think of it as an integer. and then all you have to do here is just add this element to that array, dynamic array, right? So you will just say elements of size plus plus equals element. So what we do here, the first element is added, size in this particular line will be 0, in this particular expression will be 0, and then we say elements of 0 equals that particular element. This is just an array, and maybe yeah, this is what is happening here. This single line will do that, but think about it, we are still not yet done with pushback, because we should also consider the case when the capacity is actually, the size becomes capacity, okay? When the number of elements in the vector becomes equal to 16, then we should like do something, right? So maybe at this time we can just add a if condition, okay? If size is less than capacity, then do this. If size is less than capacity, then do this. Then we are not going to add the else part right now. We can just add a to do here, okay? We can just add a to do, saying like handle case when size is equals capacity, okay? Because for this discussion right now we don't need this, but you'll be doing this for your A6, okay? And then we go here now, and then we try to add an element here. V1 dot pushback, let's say 1. See if this code is executing, it's at least compiling and executing. So now we immediately try to print our vector, okay? So we just say print vector, and it takes in a vector of in by reference VP, and remember whenever it's going to print, it should be by const reference, and it's going to return nothing, and but instead it's just going to go to a for loop. In a for loop, right now we don't have any iterators or anything like that implemented in our vector class, so we cannot use iterators right now. So just use the default indexing that we usually do. So I'll just say this is, should be v dot. Now we need the size of the vector, right, to do this. So go and implement getter for size. Go and implement a getter for the size. Okay. Size. So you have a getter for the size, and you can just call that. You can just make it as size to be consistent with whatever we have in vector. Okay. V dot size. Then we say std cout b of I. Just print the comma in between, and at the end we just print end line. Okay, this is what we are doing. So let's now we can try printing our particular vector with this one element, just to make sure everything is like going correctly. So we are just saying print vector of v1. Yeah, so now there is one more issue here. What is the issue? It says, see here, it says subscripted value is not an array. Just to even print this way, we need the operator overloading of the square brackets for our vector class. So even before we run this, first you go there, again do the operator overloading for the square brackets, okay? So that you can index the vector. So you say I'm going to overload this operator, and the thing that is going to come in is nothing but size t of index, right? And what should we return? We should return the element, right? The element is of type t, and usually you return it by a reference. And also you have, whenever you have this, you also have a const overloaded method of the same type. Maybe you can just write this code. You just say return elements of that particular index. That's it. That's all you want to do here. And you will not do any checking in this particular type, okay, for bounce checking. Because arrays index of, the array subscripting operator will not do any bounce checking, and so immediately you will do a const overloaded type. So which returns a const t, and this is also a const method, This is needed whenever we want to use this array subscripting operator in a function that is a const function. It should return the value in this array in a const way, okay? So that the person cannot modify this. And so now this should work. You see this went off. Now let's just try running this. Yeah, you see that? Just to print a single element in the vector, you'll see how much time it took. I'm saying like just to create our own vector class, but it's also cool with whatever we have learned till now. We just like are using all those features or all those tools that we have, and we have just printed our thing. Okay. And now, just let it be just the same single element vector. Now, if we are creating one more vector, v2 of v2 with v1. Okay, we are saying like I'm creating a vector called v2. It should be a copy of v1. Okay, as we just saw. But currently, when we do this, let's see what's happening. Okay, now this particular code. Okay. So once again, so yeah, these are like now some issues are taking place with respect to memory management. Okay. So now what is the issue here is this v2 that we just created. Okay, will have like a size, capacity, and elements, right? Size and capacity will be just copied to v2 because they are just like unsigned integers. But the elements that we had, which is a pointer to a dynamically sized array, okay, will actually point to the same array in this case. So till now, in the diagram that we saw, we thought, okay, if we do something like that, v1 is here, v2 is here. Now what is happening here is v1 was pointing to this array, right? And when we try to copy, since we don't have a function called copy constructor, okay, by default what it does is just it thinks that this v2 is also pointing to the same array. Okay, or you can think of this v1 is actually it contains three elements, right? One is the size, other is the capacity, and other is the elements, right? And this also will contain three things: the size, capacity, and the elements. And it will just copy size, which is 1 from here to here. It will just copy the what is this? The capacity 16 from here to here, and it will just copy this address. Okay, when you try to copy, it will just copy this address from here to here. And so the address of, let's say 0x100 is just copied here, and so now both these elements of two different vectors are pointing to the same dynamic array in P. Okay, and this is a problem because when we go to our stack, okay, so when we go to our destructor, when v1 goes out of scope, okay, when v1 goes out of scope, that destructor will be called, and it will try to free that memory, okay, on the heap. It frees it off. And when v2 goes out of scope, immediately we also try to free the same memory which we have already freed. So there is a double freeing problem here. You guys understand? You cannot free the same memory that you already freed. It is an issue. Okay? And that is exactly what is happening here. And so now we have to define, whenever we want to copy some things like this, we want to define our own copy constructor. That is a special member function called a copy constructor. So after this destructor or after this first constructor, we can just write one more constructor now, okay, which is a copy constructor. By copy constructor we mean this constructor should be called whenever we try to create an object of type vector with another type of object vector, okay, another object called vector. And so the input that it takes is const vector, reference to a const vector, and this is the other vector, okay. This is the other vector that was already created. Now we just want to pass this as the argument to a constructor and then create a vector. This is just another constructor. This is just a parameterized constructor which takes in another object of type vector to create an object of type vector, okay. Nothing fancy here, but this is a special member function called a copy constructor, okay. And whenever we have this, what we are going to do now? So we know that first the capacity should be copied for this element. So this is like this dot capacity is equal to other dot capacity. Then the size should be copied. This dot size is equal to other dot size, and then the elements should be copied, but you should not just copy the pointer, but you should just copy the elements in the heap one by one. So for that, first you should dynamically allocate memory again here. So you should say T star, okay, or not T star because you already have the elements here, okay, as your data member. So you should just say elements equals new T of capacity. Okay, with that capacity, now we have created a new dynamic array and we are just going to copy the elements in this dynamic array one by one. So from 0 to size, just go and maybe even 0 to capacity if you want, but 0 to size is enough. Yeah. From 0 to size, just go and copy these elements one by one. How do you copy that? You just say elements of I, which is this current object's element that is being created, equals other dot elements of I. Now we have made, this is what was happening inside the actual vector class, by which we are able to create a copy called v2. But now we had explicitly write this copy constructor because we are managing memory by ourselves. Copy constructor, this is called, this particular member function is called a copy constructor, and it's like a special member function, okay? And does this make sense? Any questions about copy constructor? It's just a constructor, but it is a parameterized constructor which takes in an object of the same class and creates another object. That's it. Okay. Now, if you go back here, okay, now this particular line of code is creating a vector called v2, but inside memory it is actually a new array, okay, that has been copied from v1 as it is, and then now we have v2. So now let's just try running this. At least we should not get the double free error. Let's see. Yeah, at least now we don't get the double free error because v1 is pointing to some dynamic array, v2 is pointing to some dynamic array on the heap. Once v1 gets out of scope, that array is deleted. That memory or array, you understand that, right? And once v2 goes out of scope, that particular memory on the heap that belongs to v2 now is deleted. Okay? We don't get this now. So now we can go and check, okay? Now we can just go and do like v2 of 0 equals, let's say, 3, okay? And then we can just print v2 just to make sure that this is a different vector. And maybe you should also print v1 also just to make sure we have not modified the original vector. So I'm printing both v1 and v2 here. So the first line here prints v1, which is just a single element vector. Second line prints v2, and after that we are printing v1 again just to make sure we did not modify the same array, okay? And this is what is happening here. And in a similar way, we have something called, okay, if you see here in our main, the third thing that we just spoke about, okay? If you have something like vector of n, v3, you just create a vector and you just say v3 equals v2 or something, or v1, the same thing, okay? This particular piece of code, if you try to run, now let's see what is happening, and we can just do the same things here. You can just modify, I'm just modifying v3's 0th element to 7, and I'm printing v2, sorry, I'm printing v3 and then v1 again. So see here, we are creating v3 and we are saying that v3 is a copy of v1, and we are modifying the first element in v3 to 7, and we are printing v3, and again we are trying to print v1. Let's see what is happening here. So again that error comes up, but see here, don't worry about that error right now, but see here, we modified v3, okay? So v3's first element got modified to 7, but again we tried to print v1. Now v1 also got modified, and the reason is, now again both v1 and v3 are pointing to the same dynamic memory on the heap, are pointing to the same array. And to avoid this, we need to write one more member function called an assignment operator. You need to actually overload this equals operator. Till now we were not doing this because we were not managing memory by ourselves. We were managing memory with like just use it with just like what to say containers like vectors and stuff like that, which already does these things for us. So the last thing that we are going to add here is just called an assignment operator. So just take like 2 or 3 more minutes and get this done. Okay. So the assignment operator is just saying operator equals, okay. This is, I'm overloading this assignment operator, and the type that comes inside the assignment operator, there is nothing but, you can think this is just going to be called as v3 dot operator equals of v1, right? And so you are going to say it's going to get a const vector by reference. This is the other, and then we can think about this. As of now, if you don't know this, you can just keep it as void. What should be written, if you're not sure, you can just keep it as void. And here we can just say, so this assignment also looks very similar to copying, right? So first we can just copy this code from here, okay? You can just copy this code from the copy constructor directly inside the assignment operator, okay? And see what is happening here. But here in assignment, there are some more things happening. This vector v3 that we just created here may already have some memory that has been allocated on the heap. When we just created v3, there was an array of 16 integers created. Okay? Maybe I think I need more time to explain the assignment operator, so maybe we can discuss it in the next class. I don't want to rush through this because this is actually very important, very similar to the topic constructor. This is very important, so we can just discuss this in the next class. Oh yes. See you next week. And if you have any questions, if you want to meet me, because I'll be leaving next week, if you want to meet me regarding anything about the course or anything in general, please send me an email. We can meet within the